Hello everyone, welcome to the world of chemistry. Today we'll continue our discussion with the leftover separation techniques of mixture. Those who have seen my previous videos of this chapter can understand this part of the video properly, and those who haven't seen, I would request them to see it in order to understand it clearly. The first separation technique that we are going to discuss today is sedimentation and decantation. Sedimentation is the process in which the insoluble impurities settle to form sediment at the bottom of the container when left undisturbed. Here in the diagram you can easily see the mud has settled down at the bottom, and above it the clear liquid, which is known as supernatant liquid, is present. Decantation is the process of gently pouring this supernatant liquid into another beaker without disturbing the sediments. Let's see the method. Here you can see a muddy water has been taken in the beaker. If we allow such a mixture to stand for some time, the solids tend to settle down. The liquid forms a clear layer at the top. If we remove the top layer without disturbing the settled solid, we can separate the liquid from solids. The next method that we are going to see is decantation. It is the removal of the clear liquid of present without disturbing the settled solid. The second method of separation is distillation. This is the method of separating a homogeneous mixture in which the substances have different boiling points. This method can also be applied to separate a solid liquid mixture. Here in the example we have taken a mixture of alcohol and water. The boiling point of alcohol is 70 degrees Celsius while that of water is 100 degrees Celsius. Let's see the method. Here acetone and water has been taken, and the boiling point of acetone is 56 degree. When the temperature reaches to 56 degree, it starts evaporating, and the vapor then passes through the water condenser and is ultimately collected as droplets in another beaker. This droplet of water is known as distillate. The next method of separation is fractional distillation. Fractional distillation is used to separate two mixable liquids. The meaning of it is the liquids that can dissolve with each other properly. This technique is based on the principle that one of the liquids is more volatile than the other. It means one of the liquid has lower boiling point than the other and vaporizes first. The boiling point of ethanol is 78 degree and pure water is 100 degree. Then obviously ethanol will evaporate first. Here in the example we can see crude oil is being separated by this method. The constituents of it which has less boiling point evaporates first, and the method continues. The next method of separation is sublimation. It is used to separate mixture of salt and ammonium chloride. This technique, which is used to separate solids from the mixtures, which can directly pass to vapor state upon heating, and on cooling it comes back again to the solid state. Here in the example we can see naphthalene ball, which is in solid state, directly evaporates and converts into the gaseous state. The next method of separation is separating funnel. When two immiscible liquids, means the liquids which do not mix with each other, are together mixed, they eventually form layers if left to stand. The less dense liquid forms a layer above the more dense liquid. Let's see it. Here you can see separating funnel has been taken. A separating funnel is a special flask in the shape of an inverted cone. It has a mouth at the top and a stopcock at the bottom. We have taken the mixture here and the light liquid is present above the heavier liquid. The moment we open the stopcock, we can easily take out the heavier liquid first into one beaker, and again we can close it and we can again take the light liquid in another beaker. By this method we can separate two immiscible liquids properly. The next method of separation is chromatography. Chromatography separates the components of a mixture by their distinctive attraction to the mobile phase and the stationary phase. The meaning of this definition is the compound is placed on the stationary phase. Means suppose we have taken filter paper, in that we can put the mixture. The mobile phase passes through the stationary phase. The filter paper will be put inside the beaker containing water, and the water will be the mobile phase which will pass through it. The mobile phase solubilizes the components. It mixes with the mixture present in the filter paper, and then the mobile phase carries the individual components a certain distance through the stationary phase depending on their attraction to both of the phases. Let's see it. Here you can see the filter paper has been put inside the beaker containing water, and the mixture is separated. The water rises on the filter paper and takes along with it the dye particles. The colored components that is more soluble in water rises faster, and in this way the color gets separated. Here in the diagram you can easily see how the dye or the ink spot separates in the filter paper by this method. So students, I hope you have understood well this chapter, and now it's your turn to sit and do some work. The first question is fill in the blanks. Dash are made up of same kind of atoms. Dash and dash are pure substances. In a dash, the substances are not chemically combined. Oil can be separated from water by using dash. Camphor and ammonium chloride can dash. Second question is answer the following in one word. The clean liquid present above the sediment. The solid particles which remain on the filter paper after filtration. The liquid which evaporates and condenses during the process of distillation. The process by which two mixable liquids can be separated. The process by which we can separate iron from a mixture. Question number 3. Choose the correct answer from the following. A pure liquid is obtained from a solution by. The options are crystallization, evaporation, distillation, and alteration. The next question is components of crude petroleum can be separated by evaporation, distillation, filtration, and fractional distillation. Example of homogeneous mixture is tap water, distilled water, sand and water, water and oil. A set of mixture is milk, brass, silver, honey, or ink, honey, ice cream, milk, or tap water, gold, common salt, alloy, or butter, petroleum, tap water, and iron. Students, complete this work, and in the next video we'll discuss the answers. Thank you.